Hello, today is the 4th of March and we have a today LEETCODE POTD. Check if a number is a sum of powers of 3, and this question you can read it. Okay, we have given a number integer and we have to return true if it is possible to represent this number as a sum of distinct powers of 3, otherwise you have to return false. And integer y, and we have also mentioned this integer y is a power of 3 if there exists an integer x such that y is equal to the 3 power x. Okay, and 3 to the power x. Okay, now we have a given test case n is equal to 12, so we can, if we can represent in powers of 3, okay, then we have to return true. Okay, means we can represent 12 as a 3 to the power 1 plus 3 to the power 2. We have to ensure that we can represent as a sum of distinct powers. We are not supposing let 3 to the power 1, we are taking 3 to the power 1 4 times. Not, we are not doing this, we are taking distinct powers. Okay, let's suppose if we take 3 to the power 1 time, then we can't take it another time. Okay, so for n equals to 12, we can break it into like this: 3 to the power 2, 3 to the power 1, and it makes 12. And for 91, we make it like 3 to the power 4, 3 to the power 2, 3 to the power 0. Okay, then we give 91. But for 21, we can't make it. If we, let's suppose we try to make it from n, we can see that for n is equals to 3, for power 2, 3 to the power 9. So, and 3 to the power 3 is equals to 27. So we can't power 3, we can take power 2. So while taking power 2, 3 to the power 2 is equals to 9. If we subtract minus 9 from it becomes 12. Okay, and if we going to 3 to the power 1, and 12 minus 1 12 minus 3 is equals to 9. And if we go 3 to the power 0, means 9 minus 1. Okay, so it makes 8. So it doesn't make 0 at finally, so we can't do return into a distinct powers of 3, so we are returning false. Okay, now we have a given constraint n is given up to the 10 to the power 7. So what approach we can follow? We have given a 10 to the power 7, and we know that the powers of 3 how many exist. Let's suppose let's come to the solution. Let's just come to the something discussing. Okay, 3 to the power 0, 3 to the power 0 is equals to 1. Okay, and 3 to the power 1, 3 to the power 1 is equals to 3, and 3 to the power 2 is equals to 9. Actually, we can write it up to the we can analyze that 3 to the power 5, what is coming is it's 81. Okay, 3 to the power, let's suppose we are taking 6, it coming 7 to 9, and it's actually 243. Okay, 243. Now we analyze it that it's increasing continuously, and we have to represent in this. Okay, we can represent number in this, and we have given constraints is equals to 10 to the power 7. We have given constraint that n is max up to 10 to the power 7, 10 to the power 7. So if we form a number form a powers of 3 that it makes up to the 10 to the power 7, and we are just subtract the powers of 3 from it, then we can make the number. Okay, surely. So we going to follow this approach. So we are making at most high most number 10, 3 to the power 14, which is something of 7 numbers. Okay, 7 numbers. Okay, I have just not memorized that space, but I know 3 to the power 14 is coming up to the 7 to 9 into 7 to 9 into 3. Okay, this is coming. You can calculate other things by just doing the chat, by doing saying to the chat GPT, it can calculate up to the 10 to the power 14. Okay, you can see that it is continuously increasing, and up to the 10 to the power if I am taking 3 to the power 15, it exceeds 10 to the power 7. So I can't do going beyond this. Okay, so we can just subtract it from here. Okay, so what is my approach? You can see that I just comment it or remove it. Okay, so for I is equals to 14 to I is equals to 1, I just run a loop and check if it is a power, if n is a n greater than power of 3 to the power I, and greater than is equals to 3, I just subtract it from back. Okay, I just subtracting it. Okay, I just removing it the powers of, okay, 3, and if last it becomes 0 or 1, because 3 to the power 0 is equals to 1 is also a power can exist, so I taking it, so returning true, otherwise we will return false. Okay, and this is my approach. You can just think and analyze that what we are doing in this approach. It is the most simple approach, and it taking approximate over 14 over one time. Actually, you can analyze the complexity over one time. Okay, of log n we can say, but actually we can say that it's log n, yeah, but not properly log n. It's a high at most log n. Okay, yeah, we can say it log n. Okay, so for representing log n here, we can say that log of 10 to the power 7 is our complexity, time complexity, and space complexity is 1. Okay, so for when we going to calculate this, it is equals to the it is equals to 7 into 2.8 something, which is equals to something 14.9, which is equal to constant. Okay, it's O of one space. Okay, O of one time. Okay, sorry. Yeah, you can see that. Sorry, yeah, it's taking O of one time, no? If we going to calculate it. Okay, otherwise you can say log n. Okay, if we are going to increase more in numbers, let's suppose you're going to exceed 10 to the power 7 to 10 to the power 15, 20, or let's suppose anyone, then here also the number of I increasing loop is also increase. That how, from where you are started. Let's suppose if you are going to start with 20. Okay, then you can check. Okay, if you like this solution and way of approaching me to solve this question, then you can just like the video and comment something good, which motivates me. Okay, thank you.